Administration of networks in Linux. Linux was built with networking support from the very beginning. Practically anything that you can do physically sitting at a computer, you can also do over the network remotely, and you can do this almost transparently. While this is a great feature for system administrators, it can also present dangers because an intruder could enter your system and do great damage from thousands of miles away. So we have to make sure we set up remote access privileges in a restricted manner so that we can control who can connect and where they can connect from. So let's get started. First order of business is to get an understanding of how networks work in general. We're going to talk about the hardware involved. We're going to talk about what routers and protocols are, like TCP/IP. We're going to talk about addresses like IP addresses and DNS addresses. Now, if all those terms and acronyms don't make sense to you, that's okay, because after the overview they will. And then we're going to talk about configuring our system so that it's accessible over the network to other computers. We're also going to learn how to access other computers from our computer. And we'll also learn how to control access to our computers so that only certain machines or certain people can access our system from a remote site. And then we're going to talk about remote system administration. So for our overview, there's four major components to a network. There's the hardware, there's packets, the information, there's protocols, and there's addresses. Now the hardware is just the physical stuff that's moving information around, like the routers and the wires and the cards in your computer. This is all the hardware that's responsible for making your computer communicate with some other computer. And then there's the packets, the information that's actually being transmitted between the computers. It's just broken up into small pieces called packets. And the protocols are the rules that govern how the packets are transmitted through the network. And the addresses, the origin and the destination address, helps the routers and the protocols decide how to move stuff through the network so that it gets to its destination in an efficient fashion. The underlying hardware in your network is probably Ethernet. Okay, you probably have an Ethernet card in your computer. Maybe you are hooked up on an Apple Talk network or a fiber channel network or something, but you probably have an Ethernet card. And then that card communicates over wire, and that wire is probably either a 10 base T wire or 100 base T wire. And the 10 and the 100 just stand for the number of megabits per second that can be transmitted over the wire. So obviously 100 is faster than 10 base T, 1000 base T is coming along now, and we know how quickly things move, and probably by the time I get done recording this video, 1000 base T is going to be the norm. And then after it moves over the wire, it moves to what's called a switch. Sometimes it moves to a hub or a router. But in essence, all of these things are the same, switches, hubs, and routers. Technically, they're different, but in essence, all they are is they're boxes that have a bunch of wires hooked up to them. And when information comes in over one wire, the switch determines which wire it should go out on so that it gets to the destination in the most efficient fashion. Now, the information that's being directed by the switch is what we call packets. Okay? Now, the packets, what it is it's one big piece of information you're sending, like a picture, an email message or something, and it's broken up into small pieces called packets, and each of those packets is then sent over the network independently. Okay? So you can imagine the way the switch works. A packet comes in and another packet comes in, and it's just sort of like this stream, and the switch keeps moving them through all to their destination. Okay, each of these packets has a header in it with some information, and the information in there is like the destination address, the origin address, and that helps the switch move the packet to its destination efficiently. Now, the rules that govern how the things get moved are what we call protocols. Various protocols that are in use on the internet. Some of the more popular ones are TCP, which stands for Transmission Control Protocol. There's IP, which stands for Internet Protocol, and there's UDP, which stands for Universal Datagram Protocol. Now, these protocols are not disjoint. A lot of times you'll hear the acronym TCP/IP. And what that means is that TCP and IP are being used in conjunction with each other to do the transmission. So let's explain how a transmission over the internet happens, and we explain that through this layering diagram. Okay, so think of this column here as your client machine, and think of this column over here as the server machine that you're getting information from. Well, the request is initiated in your application layer, like your web browser, for instance. You click on a link, or you say download this file or something, and the application layer then interacts with the transport layer, which is the interface to the internet. Now, the internet interacts with other pieces of the internet through the network interface layer. And once it gets over to the machine that it is destined for, then the transport layer interacts with the application layer on the server machine and says, hey, this guy over here wants this information. Then the information is sent back like this, back up to the application layer of the other machine. Another request is made, another response is made, and so on. And it kind of goes down one column and up the other column. Now down here in the Internet and Network Interface layer, this is where the Internet protocol is used. And up here in the Application and Transport layer, this is where either TCP or UDP is used. Now what helps the packets travel from one computer to the other computer in the network are what we call addresses. Those addresses range from hardware addresses to IP addresses to host names. The hardware address is the local address. This is the address of your Ethernet card, for instance. But this is not the address that we need to know to send email to somebody or look up a web page. For that, we need host names. And host names are really the same as IP addresses. And these two things are linked together through this thing that we call DNS, the Domain Name Service. So when I type in www.cbtnuggets.com into my web browser, it goes to my local name server, which then translates it to an IP address like this. Now, an IP address is made up of 4 1-byte chunks. Each of these numbers ranges from 0 to 255. That's what makes up a valid IP address. And the numbers here, this is what's used by the routers. The routers like to use numbers, us humans like to use names. So DNS is a way to link these two so that we both can be happy. Okay, so once the router maps it to the correct IP address, then there's a mapping to the particular hardware address, so it gets to the right Ethernet card. And actually, there's one more step here that I forgot to write down. It gets also mapped to a particular port. So think of the Ethernet card as like the post office, and the port as like a P.O. box at the post office. Box 25 is used for email traffic. Port 80 is used for World Wide Web traffic, and so on. Okay, if you need to start some other service, you can look it up in a book what port it normally resides on. Okay, the ports make it so that the one Ethernet card, many services can be running on that. I can have an email server running, a web server, and the ports make it so that the correct traffic is mapped to the correct service, and they can all coexist on the same computer at the same time. Okay, so now that we've given this big overview, let's move on and actually do some configuring of our system. Now, there's a handful of ways to set up networking, and I'll show you a couple of them. Either way, you have to be the root user, so I'm going to switch over. Now, one of the things that we can do is use the tool called NetConfig. This is a Red Hat tool. You can see it's copyrighted by Red Hat, and it's pretty primitive, but it gets the job done. It tells you down here how to use the tool. Tab moves between the selections, space does the selection, and F12 moves to the next screen. So the first question is, would you like to set up networking? Yes is highlighted, so I'm just going to hit the space bar. Now, to fill out this screen, you have to know whether you're using a dynamic IP configuration or a static one. You could use either one. They're both common. Okay, mine's static, so I'm going to fill out this stuff, but let's talk about dynamic for a couple seconds. A dynamic IP configuration, what this means is that when you logged on to your ISP, you would query the DHCP server. What this stands for is Dynamic Host Configuration Protocol. You would query that server and say, give me an IP address, and that thing would go through their big pool of IP addresses and select one and give it to you for this session. So that would be your IP address until you logged off, and when you logged off, it would go to be somebody else's IP address when they asked for it. Okay, so this allows someone without a whole bunch of IP addresses to serve a bunch of people. Hopefully they have enough so that they wouldn't run out of them and you wouldn't get denied from using the system. Okay, that's the only drawback to using those. So like I said, I don't have a dynamic one, I have a static one, so I'm going to hit Tab here and fill out these fields. Now my IP address that I've been assigned is 209.11.135.227. Okay, and now I'm going to hit Tab here, and it filled in this field automatically. It's not always right, and it's not right in my case. My net mask does not end in 0; it ends in 248. This net mask has to do with sort of how many IP addresses your ISP has to give you in some sense. The more zeros there are, the more that they have available in some sense. Okay, that's just a rough explanation of what that is. We don't really need to know all the details there. Now, I'm going to hit Tab again, and it took a guess at my default gateway in my name server. The gateway for me is actually address 225, the address they guessed for my name server. What the gateway is, though, is it's kind of like your front door to the rest of the internet. This is where your computer and all the other computers on your ISP's network, they're using that gateway to get out to the rest of the internet. Okay? And for my name server address, they were pretty far off because my primary one is 209.10.34.23. Okay, and again, the name server, the function of that is what we were just talking about a few minutes ago when we were saying, how do we resolve names and turn them into numbers? Well, that's the name server's job, and here's the address of my name server. Okay, so I'm going to hit Tab and hit Spacebar to say OK. And there, we're done. That was pretty easy, right? So we use this really simple tool, NetConfig, to set all that up. But you might not have NetConfig, and I want to show you how to do it anyway.